This is the PicoParker system, which tells me the distance to obstructions while parking. The idea is to make a sonar system, which is an ultrasonic ranging system that can measure distances but give it a huge display. So I made these cards which have room for a Raspberry Pi Pico here, and on the other side they have a 7-segment LED display, and there's a little edge connector on both sides which allows me to connect it up to adjacent cards and just put these side by side to make more digits. And over here I have 3 of them connected, and you can see the connector in between is simply just a header that's soldered on both sides. It's a double row header, and you can see this, the Raspberry Pi Pico is mounted on the center one. Now it can of course drive all of them, and there's room for more Picos on here, but we only need one to drive them all because the multiplexing signals are brought out across these connectors. Now on each LED card we have a BCD to 7-segment decoder, and there's a bunch of little MOSFETs to drive each segment. So the Raspberry Pi doesn't have to handle all the current. Each of these little transistors does that for us, and the Raspberry Pi doesn't have to do the decoding either. It's done by these decoder chips. So let's plug that in and show you what that looks like. But before we do that, just to note, there's a little card at the bottom here, which is a little voltage booster card, good for a couple of amps. It takes a USB input and it outputs whatever voltage you select with this potentiometer on the top here. These things can run, the resistors that I've put on there to limit the current will give me a very bright LEDs at somewhere around 8 volts out, because there's 3 LEDs in each string, so we need more than 5 volts to drive them. So that's what this little card is here, and if I plug in the USB, we'll be able to see when I turn it on that there are numbers being lit up. So I don't have the sensor connected right now. Let me do that. Over here is the MaxBotix ultrasonic sensor. And the sensor cable plugs into the card with the Pico on it. There's a connector at the back here. That's a pretty stiff cable. Okay, let's turn it on again. Now, one of the things I wanted to do was to make these 7 segments show up better and not be hard to distinguish because of the spacing between LEDs. So I printed off a bezel which has 7 sections in it, and that would just sit on top of the display. And of course we need diffusers to turn those numbers into something you can see. And I can make them brighter, but just so you can see what they look like. They're nicely formed and you cannot see individual LEDs. So let's play with this sensor. I'm just going to beam it in different directions to give us different distances. Right now it's displaying in centimeters. So that's 1.3 meters. And there's a half a meter. And down to, you can see here I'm just shining it at the wall, which is 0.3 meters away. But it works well. Just a matter of packaging it up. So let me turn on the lights again. I can crank the voltage up here. Right now it's running at about half power on the LEDs. But this bezel is going to fit into this frame like this, with the diffuser panels on top. Now, in order to get some contrast, because this is just white, I've got some very dark film here, which you can probably see through. You can see the LEDs show up better through that. Unfortunately, when they shipped this to me, it came with some very unpleasant creases in it, so I'm going to have to try and smooth that out. But that's going to go on top of the white diffuser to give us a dark surface and a high contrast with the LEDs. So another thing I'm going to do is I'm going to put some white tape over the surface of these LEDs, and I'll put holes for the LEDs just to give it a better reflection, so that we get more light coming out the front. And I'm also going to line the inside of these pockets with white tape so that we have most of the light coming out the front. So part of the reason it looked dim before is that a lot of the light's being absorbed by this black material. So I'll have to get busy doing a lot of taping, and then we can see what the final result really looks like. Okay, this is the system all together. We have the ultrasonic sensor over here and the distance display here, running from a Raspberry Pi Pico. Now, all the hardware is working and so on, but this film that I had to put on to get the contrast up, I mean, it really does work to get the contrast up. So we've got nice dark background instead of that white diffuser, and the LEDs show up as a nice contrasting red. A little bit redder to the eyeball than to the camera, but nonetheless, nice contrast. Unfortunately, this film was so wrinkly and creased that I couldn't get it to smooth out, and it ended up having all these little blotches, which sort of defeats the purpose of having the diffuser, because the LEDs, I was trying to eliminate the individual LEDs from showing up, but all these blotches just make it pretty blotchy. And if you're looking from the side, you can see all the wrinkles that I couldn't remove from the film, and it's pretty gross. So I'm going to have to find some smoother film to put on this before I deploy it. It's going to get put into the garage to tell us the distance between the car and the bench that's in there, because when the bench is in there, the car barely fits in the garage, and we need to know exactly how far from the bench we are as we park. So this will give us a good idea when we get up close exactly how far away the car is and when to stop. But it's going to have to wait until I fix that film. That stuff is just not ready for prime time. Okay, I finally have a little bit nicer tinted film in the front here, and you can see it's not as wrinkly, and it's gone together quite nicely, giving me a gorgeous display. And one thing I forgot to mention was that on these digit cards, there's a header at the middle here, which selects which chip select or which BCD digit latch is selected, so we can jumper each of these cards to have a different selection, digit selection, so that and there are 8 possible selector positions, so I could have 8 digits. We've only got 3 connected here, but this architecture can handle up to 8 digits in a row. So now I have to go put it in the garage and see if it can measure the distance to my car as I'm parking it. Okay, I'm set up in the garage and backing away from the display. I'm just walking at this point. It's not too bright in the garage, so the LEDs are actually saturating the camera. You can see below there is the sensor, and it is angled slightly up so that it doesn't get a big reflection off the floor. But eventually the sensor is seeing the walls of the garage, so that it's got a limit to how far away it will detect, because at about 3 meters it starts hitting the walls, and it doesn't go any further than that because it's getting reflections off the wall. So going back in, you can see I can get all the way into 0 right when I'm touching the shelf in front of the sensor. And it's going to give me lots of room to decide that I'm getting close to the shelf.